Hello everyone, in today's discussion we are going to learn parabola, which is a two-dimensional curve. We will learn key elements of a parabola like focus, directrix and latus rectum, and then we will move on to find out slope at any point on parabola. And parabola is a trajectory which is formed when a point moves in two-dimensional plane in such a way that is its distance from a fixed point, which is focus, and from a fixed line, which is directrix, remains same. And here we go with a problem statement, which is a JEE Advanced 2024 maths question. Problem involves a parabola which has equation x square equals to minus 4ay. And now we are going to set up our problem and solve it. We are dealing with the parabola x square equals to minus 4ay, where a greater than 0 and parameter a controls direction. So direction remains consistent with the standard interpretation of x square equals to minus 4ay, which is downward opening. This parabola has directrix at y equals to a and focus at 0 comma minus a. There is a normal which goes through this parabola through a point on y-axis which has coordinate 0 comma minus alpha. There is a line which is parallel to directrix, and this line cuts the curve at 2 points A and P. Length of latus rectum is given R, and S is the square of line segment AB's length. We have been given the ratio R is to S, and we have to find the value of 24A. Here I have also included how the length of latus rectum is calculated. The latus rectum is a chord of parabola which is parallel to directrix, perpendicular to axis of symmetry, and goes through focus. In our case, axis of symmetry is x equal to 0 or y-axis. So we first calculate endpoints of latus rectum which has same y coordinate as of the focus. We put this y coordinate in equation of parabola, and then we find out x coordinates of the endpoints of latus rectum, and then we use the distance formula in a normal way and then find out the length of latus rectum. So finally we got the length of latus rectum as equals to 4a. We are only taking the magnitude while using the distance formula, so r is equals to 4a. Next we move on to find length of line segment AB, and for that we need to find normal line equation, and by using that we will be able to find y coordinate alpha in terms of a. The point this normal to the parabola is drawn, we mark it as w. This normal has slope 1 by root 6 and goes through another point on y-axis which has coordinate as 0 comma minus alpha. We put it in a straight line equation. Y minus y1 equals to m bracket x minus x1. We found the equation of normal. We will now be using this slope of normal 1 by root 6. We will find the slope of normal on the curve by using differentiation formula. For that we have slope of tangent as dy over dx, and then we know that slope of tangent into slope of normal equals to minus 1 at any point on the curve xy. And here is the visuals and also the line equation. So we differentiate our curve equation x square equals to minus 4ay. We write it as y equals to x square by minus 4a. Then we take dy over dx, and then we have the slope of tangent which is minus x by 2a, and we can find the slope of normal which is minus 1 over dy over dx. So we found the slope of normal which is 2a by x to this curve, and we know that the slope of normal of this particular normal is 1 by root 6. So we put it there. We found a relation x equals to 2 root 6a. Because the normal is at the point w, so we got x coordinate of w in terms of a. Now we put it back into our curve equation x square equals to minus 4ay to find out y coordinate of w in terms of a. So we do the calculation by putting it, and we found out that w is having y coordinate as minus 6a, and also we have already calculated the normal line equation, which is y plus alpha equals to x upon root 6, and we have the normal line equation. We got the point w on this normal line in terms of a. So we are going to put the coordinates of w in the normal line equation because it is going to satisfy this line equation, and then we are going to find the relation between alpha and a, which is going to be through this calculation alpha equals to 8a. Next we are going to use the relation r is to s, which is 1 is to 16, but for that we need the line segment AB's length, and we are going to calculate the length segment, and for A and B I coordinate will be minus alpha as seen in figure. To find the x coordinate of A and B and then length of segment AB, we put y coordinate in parabola equation just as we did to find out the length of latus rectum. So we put the value of y coordinate, which is equals to minus alpha. We find out x coordinates of A and B. So we have coordinates of A and coordinates of B. The distance between A and B can be written as twice of the x coordinate here due to the symmetry of A and B, and also y coordinates are same for both points A and B. Then we calculated the value of s, which is a square of the length of line segment AB, which is 16a alpha, s equals to 16a alpha, and we put it in the r is to s ratio and found that 2a equals to 1. So now multiplying both the sides with 12, we come to know that 2a into 12 equals to 1 into 12, and so 24a is having the value 12. That's it. Thank you.